Hello everyone. In this video I'm going to make the geometry as a parametric, and once we change the parameter in the workbench screen, which is here, and then just clicking on the update project or all design points, this will run everything in a background like geometry change, mesh change according to the geometry, setup, solution, result. And we can define the input parameters and also as well as the output parameters. For example, in the solution, you want to see the velocity at the outlet. And now you can define this parameter as the output parameter, and the input parameters can be the geometry parameters. These can be in the meshing parameter, like we want to refine the mesh or coarsen the mesh. In setup, we can change the velocity or any other parameter here. And inside results, we also can have some input parameters for creating new planes. And for output parameter, this can be the velocity, pressure, temperature at some location or maybe some plane. And this can also, these all things can be done with a single click in a screen here. And all input parameters will be updated automatically, and all output parameters will be gotten from that simulation. And you can define multiple parameters, and you can solve them in a parallel if the license permits you, and you have enough CPU power and the RAM. And also you can run them in a series. In that case, this will take more time. So same as you run this case one by one, but that will be automatic in the automatic fashion. Like you don't have to stop solution and change the parameters, boundary condition, and then again run the solution. This will be done in automatic fashion. But in serial case, the first case is finished and second case will be started. And similarly for the further design points. So this will take some time, but if you have the licenses and more CPU power, you can run them in the parallel. And now we go to the geometry tab. The geometry design molder, we want to make this length as a parameter, and this length is defined in the extrude 2 here. And right now the length is 20 meters. And to define the parameter, we have to just click here. This will make this geometry as a parameter. But before that, I want to see that if I change any parameter, any dimension here, so are they compatible with all these parameters, these inputs or the geometry operations here? This is a very important thing, because maybe we change some parameter and we end up at some error. So we must check that which thing should be changed first before making this geometry as a parametric. And now let's say we want to change the length of this pipe from 20 to 40, 60 and 80 meters. And so I want to see that what will be the effect on the geometry. And you can see we have the error. Right click here and show all errors. So non-manifold bodies. So we have the many errors. So this error is likely because of the dimensions. They are of fixed value. For example, if I go to the extrude 4, which is right here, not defined right now. This is defined by the one edge, and this is through all. Extrude 5, which is here. Then we have the extrude 6, which is defined by this geometry here. And you can see that we have the dimension is set to the 20 meters, which was the dimension of this pipe previously. And as the dimension changed from 20 to 40 meters, now this operation is invalid here. And so I can, instead of fixed dimension or extend type, I can make this as a through all and click on generate. And similarly for the extrude number 7, which is from sketch number 9 here, which is defined here, I can make it as a through all and generate. And make sure we have 19 bodies, and now error is no more there, and all bodies are defined perfectly here. So it means that now we are ready for making the geometry as a parameter for this length here. So go back to the extrude number 2 here and make dimensions 20 again, back to 20. Click on generate. Everything is okay now. And now from here, click on the FD1 dimension here. And simply click on this location, and we can call this one as pipe large length or simply length of the large pipe. So length of the large pipe and click on OK. And now we have this parameter, and if you go to the design to the workbench, and now you can see the new operation or new option here, which is parameters number 7, and double click on parameter set. This will open all the parameters here. So right now design point first, which is design point 0 here, is displayed here, and you can also put the value, let's say 30, 40. And when you click on the update all design points, so what will happen is that this will update all the geometry parameters, and then it will make the change in geometry with the length of pipe is increased from 20 to 40 in the step up 10. And this will change the mesh properties for the second case, third case, and then for setup it will read the mesh and same boundary conditions, same other conditions, turbulence model. And this will solve the case, and it will give you results in a required format as you said in the CFD post. And if needed, you can also make the one design parameter as the output, for example the velocity at some location, and this will be displayed in the screen here. And let's say I don't want these extra design points, so I can delete them from here, and I want to just change my point over here. I make it 30, and also you can see that if you define more design points, you can also retain them in your working directory. Otherwise, they will be solved and data will be discarded. Only the data you will get is the output data which you set in the terms of the parameter. So if you want to retain this data, then you have to click here. Otherwise, they will be deleted after solution. So right now we are just changing the geometry in the design point 0. And click on update, OK, and go back to project and right click on geometry and click on update here, and then go back to design molder, and you can see that the length has been changed. The extrude length has been changed from 20 meters to 30 meters. So this is one thing which we can do. And second thing which is extra here, I just want to discuss about that thing, and I will not carry this thing forward in the next sections, in the meshing, in the fluent part, in the CFD post part. And this is just for general knowledge. This is what we can also do inside the workbench. For example, I want to make this the radius of curvature of this band here as a function of this small pipe diameter, which is 0.5 meters right now. And as we define this length as this radius as a R by D is equal to 1.5. This is for the large bands, and for small bands R by D ratio is equal to 1. So R by D means that if the R is equal to 1.5, D will be equal to the 1. And when the D is 0.5, so we can find out the R from this formula. And so the R is right now is a 0.75 as we defined when we created the plan number 6, I think, or 7 for this point over here. And so it's a plan number 6, and this is the value I am discussing about. So I want to make this as a function of the diameter of this small pipe here. So first of all, I will make this one as a function of this as a parameter, and I define this one as a radius of curvature of this band here, this 90 degrees band here. And second thing I want to make as a function is this small pipe diameter. And I call this one as the diameter of small pipe, DSP. And I will be using the parameters option from the GUI of design molder. And what I want to do is that I want to make this radius of curvature as a function of the small pipe dia, so that whenever I change the value of the small diameter, the value of RC should be always 1.5 times this value. And therefore I will go to the parameters dimension assignments tab here, and I would be, if I copy this from here, if I am permitted to do copy, and here paste this command here, and then put the asterisk sign for the multiplication and then 1.5 and click on enter key. And then you must click on check to check that everything is perfect. Otherwise, this will, if there's some error in the sentence, this will give you error. And then close this dialog box from here. And click on generate also to apply all the operations once again in the design molder. And then go back to the workbench window here and double click on parameter set. And you can see we have two new parameters, which are the RC and the DSP. And if I change the value of this second parameter, let's say from 0.5 to the 0.6, and keep in mind that the diameter of the small pipe should be less than diameter of the large pipe, and which is a fixed value at the 1 meter. If you make the value of this one equal to 1 meter, this will be making some errors, and if you go beyond this value, you will have some very strange type of the geometry things there. But if you make the geometry all parameters dependent on the one parameter, so if you change this value, maybe you can make the diameter of large pipe as a function of this parameter. So this will also change according to some ratio of this value. But right now, I will try to keep the value less than the 1. So I can go to 0.6, 0.7, 0.8. Let's say 0.8. And click on update. And go to project tab here and right click on the geometry. And then click on update. And as you can see that we have the value of DSP as a 0.8. And just check the diameter of this should be equal to the 0.8, right? The important thing here is that the radius of curvature, which is the plane number 6, should be the 1.5 times of this value. 1.5 times of this value means 0.8 into 1.5 is equal to 1.2. So this should be showing this value on the plane number 6 as a 1.2, which is here. And if I go back and from here I change the value as let's say 0.3, update, and also update geometry in the tab here. Once we define everything inside this container for fluid flow fluent, we don't need to be updating everything manually here. And then I can see there are some errors, so I want to see what is happening here. Okay, so we have some error, and the length is, I think, very small here, and so we have the collision between these two geometries. And therefore, I will go back, and from these parameters, I will make the geometry as, let's say, 0.85. Update here, and also update here. And now check the geometry here. So you can see again, we have in the sketch number 2 as a 0.85 and plane 6 is 1.275. Why? Because 0.8 into 1.5 is equal to 1.2. So 0.85 into 1.5 is equal to 1.275. So in this way, you can make the geometry parametric, and you can even with a single parameter, you can make all the parameters dependent on the one single parameter. If you change one parameter, everything will be changed automatically inside the geometry. So is the case with the meshing, fluent, and CFD post.